Today we'll be discussing the RC4 cipher. The RC4 cipher is basically a cryptographic algorithm which is used to encrypt and decrypt text. So it was invented by Ron Rivest in 1987, and it is formally known as Ron code cipher. It was kept a secret until 1994. It was published on Cypherpunk's mailing list. Cypherpunks is basically like it's a website where you can send a bunch of cryptographic algorithms. It's a community of cryptographic algorithms where they can make each other better and all that. And so basically the procedure for this is that it uses an S array of length 256 where it goes from S ranges from 0 to 255. S array is basically the key that we're using here. So let's say the key is example I am Tejas. We take as the key text. So we have to convert the values into ASCII values first. So I goes 73, space bar goes 32, A goes 65, and so on and so forth. T goes 84, S goes 115, right? So and let's say that the key array length is 256, right? So it's expandable. Even if it's just 8 here, it's expandable. We'll show you how. So 0 to 255, and the elements of the key array are repeated. So let's say that the 0th element is 73, right? As you can see here. And the 150, the ninth element is 115, right? So what should the 10th element be? The one after this. It should write loop back to the first element as previously stated. And it should show as 73. We should take that as the next value for the a key and loop it back. So it'll continue, keep going till 255, right? And we have two algorithms under RC4, basically. The two algorithms that we're going to be talking about today are the key scheduling algorithm and the stream generation algorithm, right? So we'll first go through the syntaxes of each of these algorithms. So basically, this just code explains how the procedure takes place between, when it comes to key scheduling and key stream generation. Firstly, when it comes to key scheduling, we have to initialize the j value as 0. So the j index and I index are the values we'll be taking in the S array. And we have to take j value as 0. And for I to be, and I should also be initialized to 0 to 255. You have to take it as iterations. And j should be j plus s of I plus t of I, which is mod 256. And now we swap s of I and s of j values after we find j and I. We swap them in the array, basically I and j values, and we end the for loop. So basically it just goes till the key size is over. Right. Now we have key stream generation, which is we start off by initializing I and j values to 0, right? And then we increment I by 1. After which we do j is equal to j plus 5 mod 256. Swap I and j values in the S array again. After we do that, we can find the p value, which is s of I plus s of j mod 256 as given in the formula here, and the key stream value, which is basically s of t. That is the value at s of t becomes our key stream. Right. I mean the value at index t in s becomes the key stream basically. So let's just and for encryption, this is the formula where the cipher text basically plain text XOR with the key stream, and you can see here the plain text is cipher text XOR key stream. So encryption and decryption process laid out here. Now we can look at a solved example to see how the uh, process takes place for the key stream generation and let's just say the key scheduling algorithm and the encryption decryption, as you can see all here. So for example, let's say an array of length 8 is given. So we know that S values from range from 0 to 7, right? And the key given is k equal to 0, 1, 1, 2, 3, 6, and the plain text given is 1, 2, 2, 2, right? Now we initialize the state vector S and temperature vector T, right? So we given important s and t such that s of I equal to I, so 0 1 2 3, basically the index values are there, and t is initialized such that it is the key k, which is repeated as necessary, right? So t equal to 1 2 3 6, and it just starts over again 1 2 3 6. We've already spoken about how the repetition takes place so that we can expand the key further and further. uh, we can now perform an initial permutation on S, where we initialize, we saw the formula here, we have to initialize the j value as 0 for key scheduling algorithm. So we will be putting that into practice here, where we have we take i's from 0 to 7, and j is given as 0 already. So we find j value as j plus s of I plus t of I mod 8, and we swap s of I and j, right? So let's look at the first iteration. I value is given as 0. So I value is given as 0, then j is 0. 0 plus 0 for s of I, because let's just look at the zeroth index of s, right? That's where is it? One second. If you can see, as here, the zeroth index of s is 0. So that's why we substituted 0 into this place. And similarly for t of I, zeroth index is 1. So we substituted 1 here. So we carry out all these steps to get, let's say, 1 mod 8, which is 1. And after we find out j value and I value, respectively, I is 0 and j is 1, we swap the I and j, respectively, within the S array itself, and we get a new S which looks like this, right? So we have to, how many steps do you have to carry out this for? Let's see. We have to go through the entire process. I mean, entire key. So we have to go from 0 to 7, right? So we have to check for now I equal to 1. So for the first index, let's say in the S array is 0, right? And the first index in the key array is 2. So we substitute j as of I, t of I into this formula, and we find with it the modulus of 8, which gives us 3 mod 8 and the value of 3, right? And now we swap s of 1 and s of 3, which is the first and third index. After we do this operation, we get, let's say, the first and third index of this, let's say 1, 0, and 3, right? So once we swap these, we get this. So we get 1, 3, 2, 0 in this arrangement. And now we look at the second iteration for I equal to 2. The second index is, as you can see here, it's 2. And T of I, which is in the key, the second index is 3. So we add 3, 2, and 3 and find with the modulus of 8, which is 8 mod 8, and that value gives us 0. And after we find I and j values again here, we swap s of 2 and s of 0, and we get the new s value of 2, 3, 1, 0, 4, 5, 6, 7 after swapping, right? Similarly, we find for 3, 4, and 5, let's say, we find basically what we have to do is we have to find the third element of uh, the S index and the T index, basically for when it comes to I is equal to 3. And like you substitute here, J is, you put in the J value, you put in the S value, and you put in the T value, you find the modulus of 8, which gives you 6 in this case. So I and J as 6 in this case, so we swapped the third and 6 in values. As you can see here, this is the final array that we got for that. Now that I is 4, we look at the fourth element of the S array and the fourth element of the T array, which gives us 4 and 1, and J is 6, as you can see here. So 6 plus 4 plus 1 mod 8 gives us 3, after which we swap the fourth and third element of the arrays, which gives us this equation, this array, right? Now let's look at the fifth iteration of this for I equal to 5. For the fifth, let's say you have to refer to the previous one every time, right? So just previous what happened. We look at this array. So let's look at ith index of 5. So that's 6, right? No, that's 5, right? So the fifth index of S array is 5 at the moment, right? And with this, you add the fifth index of T in array, that's 2 at the 2, because the T is always constant, right? So we add 3 plus 5 plus 2 mod 8, which is 10 mod 8, and it gives us the value of 2. And we swap S of 5 and S of 2, which we get 2, 3, 5, 4, 6, 1, 0, 7. So you swap the basically fifth index again, right? Yeah. Next up, we have we take the so we have to go till, like I said, we go from 0 to 7, right? Till we get to 7 to them, we can't stop here. So like we said in the formula, for so 0 to 255, we're taking 256 considering, but considering the key we're taking is only 8 bits here, we need only go for 0 to 7. And after you swap s of 7 and s of 2 into this, uh, for we find I of j for 6 and 7 respectively, we can substitute into this values, and that gives us these, right? Next, we find out simplified stream generation. So this is key stream generation. So we already knew that this, we've seen this syntax earlier, but let's go through it again here, where I and j values are initialized originally to 0, and this is the this is the while loop. This runs till it's true. Uh, I is I got cut off there. So let's just go through the key stream, I mean, the simplified stream generation again. First we initialize I and j values as 0. And while it's true, we first find I as I plus 1 mod 8. J is given as j plus s of I mod 8. And after we find out the I and j values, we swap the ith and jth index respectively. After you swap these two values using this new s that we have, we find t and k values. K is basically key stream and the t is SFI. So we'll just go through the solved example here to see how this can be better understood. Right. So we have s given us here 2374601 This is the last step taken from here. Right. For the first iteration, we have I is equal to 0 plus 1 mod 8, which is 1. So basically, I plus 1 mod 8 is 0 plus 1 plus 0 is I. And j is equal to 0 plus s of 1 mod 8, which is 0 plus 3 mod 8, and gives 3. We swap the first and third index of this. So let's say this and this. And we get 4 and 3, right? 2, 4, 7, 3, this arrangement. And we find the t value by adding I and j terms in s with and modulus with 8. We find 4 plus 3 mod 8, which is 7. And using this 7, we put it inside we find the seventh element of this array, which is 5 again. So we use k is equal to s of 7 is 5. We can find t and k values using this, right? And now we can go on to the next iteration. In the next iteration, let's say second iteration, we have s given as 247306015, which is the last step of this. And I is I plus s of 1. S of I is 1 in this case because yeah, because so once again. So s of I is taken as 1 plus 1. I mean, k plus 1 is 0, and mod 8 which is taken as 2. J is equal to 3 plus 5 2 mod 8. I mean, s of 2 mod 8. S of 2 is 3 in this case. I mean, 7 in this case. So we take 3 plus 7 mod 8, which is 2. We swap the second and second index. Basically, second and second index basically interchangeable because the same element, right? So it's the S array remains unchanged, and we find t and k values by adding the second element with itself. So it's 7 and 7 mod 8, which is 6 mod 14 mod 8, which gives us 6 value, and we put that into the we find that element of the S array, which gives us the key stream value for k, right? Now next we have the third iteration. For the third iteration, we can see that I is equal to so k is taken as 2 here for the third iteration, 0, 1, 2, and mod 8 is 3. 2 plus 1 mod 8 is 3 mod 8, which is 3. J is equal to 2 plus s of 3 mod 8, which is 2 plus 3 mod 8, which is 5. And once we swap the third and fifth index of the array again, we can get this array, as you can see here. And after you get this array, we can find the t and k values as we mentioned previously, just by adding the I and jth index of this array. 0 plus 3 mod 8 gives us 3 mod 8. I mean, 3 mod 8 is 3. And k is s of 3, this gives us 0. This third element is put into here. And the fourth iteration is exactly similar as the previous steps. Just with each change in the key and the swapping, you just have to reflect to the next step and go on, which you get the final key after you swap these values, right? Right. So now we go to the encryption process algorithm. The encryption and decryption process is actually quite simple. The key stream generation is a quite complicated process. This is actually quite simple. What we have to do is we've already seen that for the encryption process, we find ciphertext by doing an XOR operation between the plaintext and the key stream. So when we do an XOR operation between the plaintext and the key stream, firstly we convert the key stream and plaintext into their respective ASCII values. You can see here. So after you after binary values, as you can see here. So once you convert them to their binary values, um, and once you convert to the binary values, you can perform an XOR operation between them. Basically, the rules for XOR, as you know, are the dissimilar ones are false, and the dissimilar ones are true and similar ones are false. So let's say 1 and 1 gives us 0 here as a ciphertext result, and 1 and 0 gives us 1 here. So it's a true result, right? And since, as you can see, the same steps apply for all these steps, and you can find the ciphertext in binary format. After which you can just convert it to decimal format just by putting 8421 over them and just doing the 2 power 10 addition. You can find 4323 as the ciphertext, right? For the decryption process, you simply have to do the same reverse step and XOR the operation for the ciphertext now, do the XOR operation for ciphertext now, and you can see your ciphertext values has been converted into binary. Key string values are converted into binary. And with this, we find plain text using XOR operations, same rules as before, where that the similar ones are false and the dissimilar ones are true. So let's say the similar ones are true, as you can see here. Similar ones are false, as you can see here. And we receive the plain text after converting this into decimal format, and we receive the original plain text that we got in the question. So yeah, we can with this we can say that the algorithm works. Thank you.